Hi everybody, once again, welcome to 7.5, and this is where we're going to talk about dilutions. A lot of times we want to have, we don't want to just make a solution from scratch, and so we can take a more concentrated solution and add more water to it and make a lower concentration solution, and so sometimes we call those stock solutions. We can make a large amount of a very concentrated solution and then just dilute it into a less concentrated when we need to use it. So in a dilution, you're going to add water to increase the volume, and that therefore you decrease the concentration. The mass of the solute will remain the same, but you just increase how much water you have it dissolved in. So when you're making orange juice, I don't know many people who still do orange juice like this, but maybe you do. But like in the olden days, kids used to get it frozen in these cans, and you would put it in the pitcher, and you'd add 1 can of orange juice and 3 cans of water, and so you'd have 4 cans worth of orange juice. So basically you've got concentrate that you dilute to form the right mixture. Because if you drink this right here, whoo, it's very, 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 very sweet. So you got to dilute that out so that it'll be tolerable. So the rule is that the moles of the solute are going to have to be the same in the original solution as in the diluted solution. So basically what that means is that you will have concentration 1 times the volume is equal to concentration of the second solution times the second volume. In molarity, it's the same basic thing. It's just the first molarity times the first volume equals the second molarity that you end up with, the diluted one times the new volume. Okay, so an example of this is, what is the final concentration when 0.5 liters of a 6 molar hydrochloric acid solution is diluted to a final volume of 1 liter? So first you just need to recognize, okay, the first concentration we're talking about is the 6 molar. So that's C1. It's asking what the final concentration is, so that's going to be C2. That's what we're looking for. The first volume is a half a liter, okay, and the second volume is going to be 1 liter. So we've figured out, we've taken inventory, we know what we're starting with. Then you're going to rearrange the original M1 V1 equals M2 V2 and solve for M2 because that's what we're looking for. Okay, and so then you just substitute in 6 molar times 0.5 over 1 gives you 3 molar. So what that means is that if you dilute 0.5 liters of 6 molar hydrochloric acid and bring it up to 1 liter, you have made an entire liter of 3 molar hydrochloric acid. So what volume of a 2% mass volume hydrochloric solution can be prepared by diluting 25 milliliters of a 14%? Okay, so you've got 25 milliliters. Alright, so let's take inventory. So the first concentration is what? It's really, this is the second one, even though they put it first in the question, because you're diluting a 14%, because you can't make a more concentrated solution from a dilute solution, so just kind of keep that in mind. So C1 is 14%, and V1 is 25 milliliters. C2 is going to be 2%, and V2 is going to be what we're looking for. Okay, so C1 V1 equals C2 V2. We're solving for V2. So V2 equals C1 V1 over C2. So V2 equals 14 times 25 divided by 2. Am I right? Okay. So 14 times 25 is 350 divided by 2. So I'm getting 175. Milliliters. Yep, that's what they got too. Yay. Alright. What is the percent mass volume of a solution prepared by diluting 10 milliliters of 9% sodium hydroxide to 60 milliliters? Okay. So we've got 9, so the first concentration is 9%. The volume, let's see, is 10 milliliters. The second we're trying to get to is what we're looking for, right? The percent. And then the second volume is going to be 60 milliliters. So this time we're looking for C2. So C2, you remember? C1V1 equals C2V2. C2 equals C1V1 over V2. So C2 equals C1V1 over V2. C2 equals 9% times 10 milliliters divided by V2, which is 60. So C2 is going to equal 90 divided by 60, basically. And I get 1.5%. So what's that telling me? It's telling me that if I take 10 milliliters of a 9% solution and add enough water to bring it up to 60 milliliters, it'll now have a new concentration of 1.5% mass volume. Even though it's math, it's not that hard, right? Okay, what's the molarity of a solution prepared by diluting 0.180 liters of a 6 molar to 0.54 liters? Okay, concentration 1 is what? 0.600 molar HNO3, which is nitric acid. Your volume is 0.180 liters. You're looking for the molarity. And so your second volume is going to be 0.540 liters. Alright, so remember what this means is that this is moles over liters. Now, I may not need that this time because I'm going from molarity to molarity. Alright, so I don't. Just always remember what that is. Okay, so this time I'm looking for and instead of C, if you want to say M, so you can remember you're looking for molarity, M1V1 equals M2V2. So M2 equals M1V1 over V2 equals, you see why I go ahead and take inventory first so I know what I'm doing, times 0.180 divided by 0.540, and these are liters, cancel, so that's going to leave me with molarity, right? Alright, so then I just do my math. 0.600 times 0.18 is 0.108 divided by 0.540, and I got 0.200. Let's see how we did. And we did again. Yay. We're on a roll. Alright, so that's how dilutions are done. This is the end of 7.5. We've only got one more and we'll be done with this chapter. So I will see you back for 7.6.